Hello, this is my code base for Doceree ML Hackathon Round 2. The problem statement states to find whether the given data is HCP or not and find the related taxonomy ID for that machine. We first start by importing the necessary libraries for the processing and creation of our model. We import both the trained dataset and test dataset here. We see how our trained dataset looks like, and this is how our test dataset looks like. Now performing some basic EDA and visualizations to get to know different types of abnormalities in our data and different methods which we can apply based on the data given. This is the bar graph for platform type. Similarly, this is a bar graph for device type in the dataset. Here we are splitting all the keywords to create the word cloud model for better visualization of important features or important keywords inside of this column. So here we use the NLTK library and the word cloud to create the word cloud model. So this is how our word cloud model looks. This is the word cloud model for is HCP equal to 1 in the training dataset. This is the word cloud model for is HCP equal to 0 in our training dataset. Now performing some basic EDA to process the data. We fill the null values in these two columns using the mode of the column. So these are all the columns inside of our trained dataset, and these are all the columns inside of our test dataset. We are missing the rows. We are dropping the rows which contains null HCP values. Now we label encode the train and test dataset to change the categorical values into numerical values so that our model can easily train on the numerical values. To train to label encode both the train and test, we first concat them and then apply label encoding on those merged dataset. This is what our merged dataset looks like. Now after label encoding the merged dataset, we again split it back into the trained dataset and the test dataset. All the relevant comments are mentioned on what step is being performed. Now we will prepare our trained dataset for both our is HCP model and our taxonomy prediction model. So now we move on to prediction of our is HCP. So we take in these as the featured columns to train our model on. And is HCP is our final prediction value. We store them in X and Y. And our test dataset, which is for which we have to predict the HCP value, is stored in the testing variable. This is some of the EDA. We then split our dataset into train and test. Here we are applying the randomized search CV to find the best parameters. As it took a long time to run, we have commented out the code and the optimal best params have been chosen to create our model based on the output of this. So on running the randomized search CV, we get these parameters to be working as the best for the given dataset. So we apply the XGBoost classifier on the train and test dataset and get this accuracy. We then predict it on our unknown and test dataset. We get these HCP values and we store them. So we can see that we get 20,057 non-HCP and 8,436 HCP values. Now we move on to taxonomy prediction. So these are the selected featured columns for taxonomy prediction along with the is HCP which is predicted from the previous step in the test dataset. So the test dataset is enumerated with the is HCP data as well alongside the is HCP data here as well. So this is the dataset which is going to be used as a train dataset for our prediction of taxonomy. We also apply random search CV here to get the best params possible for the random forest classifier here. We are using random forest classifier here instead of the XGBoost classifier because random forest classifier tended to give better result compared to XGBoost classifier for taxonomy prediction, which was calculated based on the evaluation matrix of validation data. So these are the best patterns for that. Running the random forest classifier and predicting. So these are our taxonomy. These are our predicted taxonomies. We then reverse label encode them or inverse it to get the actual taxonomy IDs. We inverse transform it. And we then replace the NaN with -1 as it was mentioned in our problem statement. And this output is stored in this file. And this is our final submissions.txt file, which consists of ID and taxonomy. This consists of ID, taxonomy, and is HCP. We had also used the lazy classifier to find out which model works best on the given data. Lazy classifier works as an middleware which tests our training data on all the algorithms possible for supervised learning and gives the accuracy for each of them. This also took a long time to run, so we have removed the output and selected random forest and XGBoost from the output given by this model. Thank you.